Our video for today is going to cover proportions, how we set them up, how we solve them, and then we'll go through some story problems and see how we can work with proportions in those as well. So let's start with our basic definition of a proportion and what I recommend we use to set these things up and kind of the ideal version of proportions if we can have it set up this way. So it's an equation of the form A divided by B is equal to C divided by D, where both of these things are written out as fractions, and B and D are not equal to 0. This is really just a fancy way of saying the denominators are not 0. That way we don't have any division that's set up by, or division by 0, I should say, showing up in these problems. Divided by 0, bad things happen, and we don't like that. This can also be read as A is to B as C is to D. We see some story problems that are written out this way, and while the language is kind of clunky when it's written out like this, this is how we translate that into an algebraic equation. Now, all of our previously learned methods that we had for equations are all still available to us here. We can still use them, and we probably will still be using them as we're going through and solving these. That said, if we have a setup where we have a fraction equaling a fraction, we can use this new method and this new process that's referred to as cross multiplication to speed up the process. What this effectively means is if I have a fraction equals a fraction, like I have right here, I can take the numerator of the first fraction and multiply it with the denominator of the second fraction. This is where we're getting A times D, AD here, and that's equal to the denominator of the first fraction multiplying with the numerator of the second fraction, in this case B times C, like we have here. So our result is two things multiplying together on either side of the equation. They are equal to one another, and the great part, more than anything else, is that the fractions are gone, and we can solve this resulting equation using all of our previously learned methods. Now, it should be noted here, if you are writing any of these notes down for yourself, oops, the thing is glitching on me a little bit. There we go. If you are writing any of these things down for yourself, which I recommend that you do, a huge warning to you right here should be taken. I would, I'm using some red stars with it, but I do something to highlight it to yourself to say, hey, big warning as we're going through and working with this. We can only use this cross multiplication trick if we have a fraction equal to another fraction. If there is anything else where we have addition or subtraction on either side of the equation, then cross multiplication will not work. I have seen and heard of some people trying to find workarounds with that to make it actually work, and at best it works in very, very, very specific situations where people got lucky that it worked, so I would not recommend making that a habit or looking for to see if there's a trick around that and make that a habit there. So what I mean by this, and we're going to go through these 4 examples here in a bit more detail, but to really highlight this, notice how in our first 2 examples we have a fraction equals a fraction. We can use cross multiplication here. We have a fraction equals, admittedly, a grosser looking fraction, but everything is still contained inside of one fraction, so I can use cross multiplication here. Now with example 3 and example 4, I have a fraction and then something is adding or subtracting to this side, in this case adding. The other side is a fraction, but because I have this addition happening outside of a fraction, I cannot use cross multiplication right from the beginning here. We'd have to use a different strategy and figure out a different way to get to that answer. Similarly with number 4, we notice that both sides of the equation have a fraction, awesome, but then something is adding or subtracting to either side of the equation, which tells me that I cannot just jump to cross multiplication to get to the final answer here. So we'll go through a couple strategies, or at least a strategy that you could use to solve problems like this. We still want to get to using cross multiplication, but there are some workarounds that we could take with those. So with that, let's dive into our first 4 examples and see how we go through and solve these proportion problems. Our first example gives us 87 over n is equal to 48 over 16, and we are told to solve this equation for n. Thankfully, we have a fraction equals a fraction, so we can go ahead and use our cross multiplication strategy. Now, I recommend writing out something here to show that numerators and denominators are multiplying together, and I would also recommend taking one line to actually just write out here are the individual things multiplying together. We're going to see and have problems get more complicated than this, so I think it's good to get in the habit of writing things out for ourselves first, and then we calculate later. Now, 87 times 16, I am calculating this with a calculator off screen. That's going to give us 1,392. Well, maybe if it'll let me write. There it goes. 1,392. Perfect. So I have 48n is equal to 1,392. And now, because this fraction is gone, I can solve this thing like I would normally, like we did earlier in the Chapter 2 problems. So I can divide both sides by 48. And I don't know what this number is off the top of my head, so again, I'm going to apply the calculator. 1,392 divided by 48. That's going to give us 29. And just like that, fractions are gone. We have a problem that looks very similar to what we've done in the past, and we have our final answer. Our second example has us working with the proportion 12 over x is equal to 36 over x plus 4. And we are looking to try and find our x values here. Now you might be looking at this, specifically the right side over here, and say, hey, well I have addition taking place on this right side of the equation, and therefore I can't use cross multiplication. And while it's a good thought to be looking for that, the nice part about this is that this addition is contained within the denominator of this fraction. So we can look at this and think, well, yeah, I do have addition subtraction, but it's all contained inside of the fraction itself, admittedly making this denominator pretty gross, but it's all still a fraction equals a fraction. The denominators might be nice, they might be gross. Either way, we kind of don't really care. It does mean, though, that cross multiplication is fair game. So let's go ahead and do that. So I'm going to have 12 multiply with this x plus 4, and I'm going to have x multiply with 36. Again, I highly recommend that you take one line of work to write this out and just show what are the things that are multiplying together. A lot of people want to skip this step and they want to jump just to, oh, the result is 12 times this and 12 times that and x times blah, blah, blah. But I tend to find that sometimes we might miss that we need to apply the distributive property here. Some people will just write in 12x plus 4 when it should be 12x plus 48. Maybe you're going through this problem and trying to get ahead of things, and maybe you did that. Maybe you forgot to make this a 48. So be aware of that moving forward to show your work and avoid that error showing up. So we simplify both sides of this equation. Awesome. Now we're solving it just like a problem from Chapter 2. I'm subtracting 12x from both sides. It's the variable with the lowest valued coefficient in front of it. Getting 48 is equal to 24x. I'm dividing both sides by 24 to get x all by itself. And I'm getting 2 is equal to x. If you wanted to do a rewrite of this, you absolutely could. Just make this x equals 2. Example 3 here is where we start to see some weirder things showing up. We now no longer have a fraction equals a fraction. We now have a fraction plus something equals a fraction. So initially, looking at this thing, this plus 1 is not contained inside of this fraction at all. It's outside of that, meaning we have an extra term, which ultimately means that at this point in time, I cannot use cross multiplication to get to my final answer. So we have to figure out and see if there's a different strategy or some way that we could rewrite this problem to get it into a form where we could solve for and find our final answer. So as we're looking at this, let's notice the fact that, okay, I have a +1 here, so I'm probably going to have to do something with this. The fraction on the other side, this 9/4, well, that's just a whole number. Or that's not really, I shouldn't say a whole number, that's just a number. There's no variable that's attached to it. So I can go through and I can actually move this +1 to the other side and combine all of my numbers, my constant terms, together on this other side. So let's go ahead and do that. I'm going to subtract 1 from the left side. I'm subtracting 1 from the right side. That means I'm going to get y/4 is equal to 9/4 minus 1. Simplifying the right side a little bit more, 9/4 minus 1, that is going to be equal to the fraction 5/4. And looking at this now, we notice, wait a minute, hold on, these fractions are almost the exact same. Y/4 equals 5/4. Well, the denominators are the exact same here, which means that these numerators would need to be the exact same. So you could go ahead and do cross multiplication, this y times 4 and this 4 times 5, if you wanted to, or we can notice, because the denominators are the same, the numerators also have to be the same. So I can just do y equals 5. And there I'm going to have my final answer. Now that is a bit of a shortcut that you can use within this. If you wanted to go through, like we did with our previous problems, and do cross multiplication between these two fractions, you absolutely could. It would probably add 1 or 2 lines of work to your problem, but you would still get to the exact same answer at the very end. So either route you'd want to take is perfectly acceptable with a problem like this. In our fourth and final example of these mechanical problems with proportions, we're seeing something where, yeah, we've got addition and subtraction showing up on both sides of this equation, meaning we can't jump to using cross multiplication at the very beginning. We have to do some algebraic manipulation of both sides of the equation before we could potentially do that in this problem. So let's look at our fractions first and see what those tell us. In our first fraction, we have a plus 1/3. Our other fraction is a/6. Okay. Not great that we have variables in both of the numerator places. That can make things potentially a little bit more complicated. But what's nice is we have no variables in the denominator spots of these. And that's going to open up another potential option that we could use later on here. What else do we notice? We have this -2 on the left side. We have this +1 on the right side. So I have a fraction plus or minus something equals a fraction plus or minus something. Again, I can't use cross multiplication here because of something being added or subtracted outside of the fractions. So we have a couple routes that we could take. We could try and move everything to all the fractions to one side of the equation, all the constants to the other side, maybe see if we can find a common denominator between these fractions and then combine them together. It is a perfectly valid choice that we could use here. One that we are going to use is slightly different from this though. Noticing that our denominators here all contain just numbers, meaning there's no variables in there at all, I could go through and use the process from, I believe it was the 2.6 video, where we're solving equations with fractions and decimals, and I could go through and I could eliminate all fractions in this entire problem. Just one optional route that we could take. I'm going to go through and use that for this problem. So I need to determine what's the lowest common denominator between all of my fractions. Well, between 3 and 6, the smallest number that both 3 and 6 could multiply into is going to be 6. So that means every single term in this problem, whether it is or is not a fraction, is going to have to get multiplied by 6. Now the reason that we are doing this, again as a bit of a refresher, is to eliminate all fractions in this problem. On the left side here, I have this 6 and this 3, they are going to reduce down. The 3 is going to become 1, the 6 is going to become 2. Both can be divided by 3, and that's where that's coming from. So my result is going to be 2 times a plus 1. My next part here, I have minus 2 times 6. Well, 2 times 6, there's no canceling that's going on. This is just going to give me 12. On my next part, I have a 6 in the numerator, 6 in the denominator. Each of those will cancel out. They can be reduced down by 6. So I'm going to end up getting 1 times a, which I can just write in as a simple a there. And then 1 times 6, well, that's just going to give me 6 at the very end. And right now, I'm looking at this thinking, hey, this is something that we covered in our very first video for this material. It's a 2.1 to 2.3 problem. So I'm going to simplify both sides of this equation first. I'm going to distribute this 2 through to everything on the left-hand side. And I'm going to get 2a plus 2 minus 12. Nothing's happening to the other side, which is fine. We're just going to bring it down exactly as it is. I can further simplify the left side by having this positive 2 and this minus 12 combined together. That's going to give me 2a minus 10 is equal to a, whoops, should be a. There it is. A plus 6. And now from here, I have a's on both sides of my equation. I don't want that. I want them all on one side. So I'm going to get rid of the one with the lower coefficient. So I'm subtracting a from both sides. I get a minus 10 is equal to 6. And I'm almost done. I want a all by itself here, so I'm going to add 10 to both sides of this equation. And I'm getting a is equal to 16 as my final answer. Now again, it should be noted that while I use the process of eliminating eliminating denominators of fractions, I should say, you are not required to use that for a problem like this. Again, you could move fractions over, combine them together, move integers over to the same side and combine those together, and maybe see if you could do cross multiplication from there. There's a lot of options that you could take here. So don't feel like this is the only one that you could use. This is just one route that I do want to show. And the fact that previous material does come up and can still be used with these problems, even if we have proportions showing up here. Now, the last part I will note, and this is unique to if you are taking my class that covers this material, if we have something like this showing up in the homework or a test or anything like that, I do not plan on having denominators like we have here have variables in them where you could use this process. So if you are thinking, oh, I could use this to eliminate the denominators and go from there, yes, you absolutely could. You can fully expect that I will not be testing you on problems that have maybe this is 3 minus a and this is 6 plus a or something like that in the denominator spot. So if it's something a bit more complicated like this is the method that you could use, and I'm not going to throw variables into the denominators of any of these fractions. That's something that we save and we see more of in the Math 97 or Algebra 2 material. The last part with proportions that we want to discuss is story problems, how we set these things up and how we go through and solve them for ourselves. So if you're looking at the textbook, page 972 has a proposed strategy that we're going to go through, but I'm going to show you 2 ways that you can organize this for yourself. For either of these methods, the big thing that we want to do is make sure that we are labeling the numerator and the denominator of the fractions for a specific unit. The problems that are going to be given to you need to specify some sort of units within them, and those are going to be very, very useful in telling us how we are going to set up our fractions and therefore allow us to solve them afterwards. When we're going through and labeling these things, the ordering of which unit does or doesn't go where, which number does and doesn't go where, specifically the units, doesn't really matter. We just need to assign them and then be consistent throughout the rest of the problem. I recommend as you are going through this, if you're writing notes down for yourself, start this last part. Do not rush the setup step for story problems. We're going to take a look at these two examples right down here using two different organizational methods, but I really want to emphasize how important it is to do this labeling and take care and take some time when we're doing these setup steps, because it's going to make the actual solving process way easier compared to what a lot of people want to do with these. So as necessary, I'd pause the video, write these problems down for yourself. We're going to go over and take a look at and solve each of these using two different organizational strategies. Let's take a look at our first story problem that we have here. We're told when looking at a map, 1.5 inches is equivalent to 5.5 miles. The first question is asking us how many miles is 9 inches equivalent to? This is a very common sort of setup for a lot of proportion problems. We're given some sort of equivalency between two things, inches and miles. Another common one that we see is the cost of something versus the amount of items you're buying. The number of apples I'm buying for this price. The other one that is pretty common that we see is currency and exchange rate. Some number of US dollars for euros, some amount of euros for pounds, things like that. So we're equating two numbers or equating two units, and then from that we're trying to find another equivalent comparison using those same units here. My recommendation is starting off with this. Let's put the general equation somewhere nearby for ourselves. So we know we're going to have A over B equals C over D. We really like proportions in this form because then we can just cross multiply and get to our final answer. Now we're going to go through two ways of going through and solving these things, and specifically setting them up. We're going to use one method for the first example. We're going to use a separate method for the second example, but at the end of the day, both of them can be used for any kind of proportion problem. I just want to show you a couple methods that you could use, and then you pick which one you're most comfortable with. So the first method that we're going to have is we're going to set up a fraction equals a fraction for ourselves. This is the form we want it to be in, kind of like our general form here. So I'm just setting up the shell of my answer or my setup for myself as necessary. Now I've been given two units here. I've been given 1.5 inches and 5.5 miles. The numbers are kind of irrelevant right now. We're specifically looking at the units, inches and miles. We need to now choose which unit is going to be listed in the numerator of this fraction and which one's going to be in the denominator. Now it really doesn't matter which unit goes where, you just need to pick one and go commit to that. So for the purposes of this, I'm going to put the inches in the numerator spot, and I'm going to put the miles in the denominator spot. Again, you could flip this for yourself if you wanted to, but I'm just electing to write it out this way here. Now, I've been told 1.5 inches is equivalent to 5.5 miles. So inches is in the numerator, so I have 1.5 inches, and that corresponds with and is equivalent to 5.5 miles. So 1.5 inches, 5.5 miles all go together in this one fraction. Now for my first question, how many miles is 9 inches? This 9, that's an inches amount, so I know that that's going to go in my numerator part. How many miles is that equivalent to? Well, I don't know the number of miles, so I could write this in as x, or m, or a, or b, or any variable that I choose. I'm going to go ahead and use m for miles, only because that's a little bit easier for me to keep track of. I'm tracking miles, I'm trying to find miles, I'm going to use m for miles. But what's really nice about this, after we've done this setup, now I have a fraction equals a fraction, and I can just go ahead and use cross multiplication to get to my final answer. So I'm going to have 1.5m is equal to, I'm going to have 9 times 5.5. I don't know what that number is off the top of my head, so I'm going to do that calculation off screen really quick. That's going to give me 49.5. Okay, so 1.5m is equal to 49.5. I need to divide both sides by 1.5. And I'm getting that m is equal to, again, doing a calculation off screen, m is going to be equal to 33. So there I have my final answer. I know that this thing, or these 9 inches are equivalent to 33 miles. Now we're going to take a look at the second part of our story problem here. We're now being asked how many inches is 32 miles equivalent to. So before we were given inches and we were solving for miles, now we're given miles and we're solving for inches. So like we did with our previous problem, we're going to set up the shell of our problem for ourselves. We want to have something, some fraction equals some other fraction. Now I'm going to use a slightly different organizational method than we used in our first example. You're welcome to use this one. You're welcome to use what we did in the first example, but either one you want to use, I just pick one and commit to it for the problem. We are still going to be looking for and identifying what are the units in this problem. In this case, we still have inches and miles showing up. So before, we had inches assigned to the numerator spot. We had miles assumed and assigned to the denominator spot. We're going to do it a little bit differently here. We're going to assign this entire fraction to be 1 unit and this entire fraction to be the other unit. Again, doesn't matter which one is going to which fraction, but we need to pick one and commit to it. So I'm going to do inches for the first fraction, and I'm going to do miles for the second fraction here. Okay. Now, with this problem, I'm still told 1.5 inches is equivalent to 5.5 miles. So I need to figure out, am I going to put this equivalency in the numerator spot or the denominator spot? And I'm going to put it in the numerator spot because it was given to me first. So I have 1.5 inches. I have 5.5 miles. These things are equivalent and they're on the same spot in the fraction here. Now for our particular problem, we're asked how many inches is 32 miles equivalent to. So in this case, I don't know inches, so that's going to need to go down below here. I'm going to use x to represent inches because I don't want to use I. That's an imaginary number, and things get weird if we bring imaginary numbers into things. I also been told I have 32 miles for this one, so I'm going to put the inches over here, the miles over here, and now I have my setup. I have a fraction equals a fraction, and I can go through and do cross multiplication to get to my final answer. So after doing that, I get 5.5x is equal to 1.5 times 32. And again, doing these calculations off screen with a calculator, you're welcome to use that as well. I get 5.5x is equal to 48. I want to get x by itself, so I'm going to divide both sides by 5.5. And I'm getting 8.727272, and it repeats on and on and on forever. Now we were told to round to the nearest, I believe it was, yes, 2 decimal places. So my final answer for this is going to end up being 8.72 inches. So again, just an alternate method for going through and setting up this story problem compared to our first one. Either method that you would like to use to organize this and do the initial setup for yourself, like we did right here, is fair game. I think they're both reasonable. They both have their strengths and pros and cons to one another, but just make sure you're picking one of those methods for the setup and then committing to that as you're going through and solving these types of problems. Bringing things together as a quick recap of our proportion material, we had our general setup that we covered, a fraction equaling a fraction. If we do have that showing up with these types of problems, then cross multiplication is an available option to us that we can use to speed up the solving process. Remember that cross multiplication can only be used if we have a fraction equal to another fraction. If we don't have that showing up, as we saw with our third and fourth examples, the mechanical problems here, then we can use any of all of our previously learned methods to go through and solve these things. Sometimes we will use those exclusively. Sometimes we'll be able to do a little bit of manipulating to now use cross multiplication. It depends on the problem. So be open to using previous methods as well as cross multiplication to get to our answers. We had some story problems that we went through as well. We went through two different organizational strategies that we can use to set these things up for ourselves. Doesn't matter which one you would like to use. Regardless of that choice that you make sure that you are correctly identifying units that are given to you in these problems, because that's going to help you organize these things instead of putting random numbers in random places and getting answers potentially wrong by doing that, because that's effectively guessing, and we don't want to be doing that. So moving on from here, the last little bit, we do have some problems that you can try on your own. Remember our strategies that we use, the cross multiplication, to get through and solve these things. We'll scroll down to the answers for each of these as well. And that's going to do it for everything that covers proportions, how we set them up, and how we solve them.